Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9. We'll be present about Engineering Mathematics Application of Ordinary Differential Equation ODE. Okay, so this is our group member. You can see we are 6 members in our group. Okay, so let's start it.
Introduction of ODE. What's a ODE? ODE is a branch of mathematics involving unknown function and their derivative based on one independent variable such as time or space, used to model dynamic system that change over time, predict system behavior from current condition, used in simulation, analysis and control design, solve complex system using numerical method, important in marine engineering, and the last is essential tool for solving real-world engineering problems. Next is difference between first order and second order of ODE. First order ODE involves only the first derivative, and this is the formula of first ODE. Describe system with simple rate of change. The example is changing in the RC electrical circuit. The second is second order of ODE. Involve up to the second derivative. Describe system involving acceleration or curvature. Example is spring mass damper system of RRC circuit. Why ODE are important in engineering? The first is mechanical engineering, modern vibration and damping system. Help design shock absorber to reduce impact and improve ride comfort. Predict how medical system respond to external forces. Next is electrical engineering. Analyze current and voltage behavior in RRC circuit. Enable design of filter, amplifier, and automatic control system. And the last is understanding circuit response to AC signal and voltage change. The last is on marine engineering. Model ship if motion caused by wave. Allow prediction of ship stability under differential condition. Support design of stabilizers for safe and more comfortable voyage.
Okay, now let's go to the application 1, which is Newton's law of cooling. What is Newton's law of cooling? It states that the rate at which an object cools is proportional to the difference between its temperature and the surrounding temperature. For real-life application of Newton's law of cooling, ODE is predicting how quickly a hot object cools in a cooler environment. For example, a cup of coffee left on a table will gradually cool to room temperature. This process follows Newton's law of cooling, which use ODE to model temperature change over time. It's also applied in engineering for designing cooling system and forensic science to estimate the dead body from the temperature. Second is ODE explanation. This process follows Newton's law of cooling, which states that the rate of change of an object's temperature is directly proportional to the difference between the object temperature and the ambient, which is the surrounding temperature. In other words, the greater the temperature difference, the faster the object will cool down over time. So this is the formula for Newton's law of cooling. Thank you.
So now we are going to solve the ODE by steps. So firstly, we are going to separate the variable. We're placing t terms on the left side and t terms on the right side. So we are going to get this equation, and we integrate the equation both sides. We integrate, and we got ln t minus ts equals to negative kt plus c. So we are going to turn the equation to exponential form, and then we get the equation. So from that, we are going to constant the integration, and we apply initial condition in the equation. So we are going to get this equation, and we got the final equation. So for example, the initial temperature of the coffee is 90 Celsius, the emission temperature is 25 Celsius, and the cooling constant is negative Fahrenheit. On the example, the initial temperature of the coffee is 90 Celsius, the emission temperature is 25 Celsius, and the cooling constant is 0.05. So we are going to calculate the temperature of the coffee after 10 minutes have passed. So the initial temperature is 90, we get the emission temperature is 25. So the constant is 0.05 and the time after 10 minutes. So we are going to solve the solution using the step that I have explained before, and then we get the temperature of coffee after 10 minutes.
Next, we're gonna look in application 2. Application 2 is about spring mass damper system in engineering. What is it, spring mass damper system? It's a mechanical model consisting of mass, represent the objects, spring, provides restoring elastic force, and damper, C, resist motion using friction or fluid. Real-life application of spring mass damper system. We can look in car suspension systems, spring absorbs road shocks, damper reduces bouncing, robotics for control motion, machinery to prevent harmful vibration, earthquake-resistant building to manage structural oscillation. What is the purpose of spring mass damper system? It's about to minimize oscillation, quickly return to equilibrium, and improve safety, comforts, and performance. Next, ODE explanation. The motion of the spring mass damper system follows Newton's second law, which states that the net force acting on the object is equal to the mass times its accelerations. In this system, there are three main forces, which is the spring force from the Hooke's law, the damping force from the damper, and the inertial force due to the mass. This is the ODE we use. The motion of the spring mass damper system follow Newton's second law.
Okay, next is example for application 2. Okay, given mass equals 1 kilo, damping coefficient 2 Ns, spring constant K equals 9 equals 5 Newton, and initial displacement equals 4.1 meter, initial velocity given O. Okay, first we write the ODE x double dot plus 2 dot x plus 5x equals O, and we assume the solution xt equals E, and next we find the characteristic equation like in number 3, and we solve that we can get negative 1 plus negative 2i, and then we write the general solution xt, we can get E bracket A cos 2t plus B sin 2t bracket, and then to apply the initial condition we can get this and the final answer like that. In conclusion, in that case, solving ODE allows prediction of motion and control of vibration.
Okay, so we back again with me. So for the conclusion is we know that order are very important in engineering because in dynamic physical system need a powerful mathematical to describe it. So Newton's law of cooling and spring mass damper system teach us how to solve a problem in engineering. Like Newton's law of cooling teach us about how to predict temperature change over time in field like thermal engineering and forensic science, while spring mass damper system model motion and vibration in mechanical and automotive engineering. So, lastly, mastering the order can be useful for engineering future because it's not only enhance analytical skill but also empower engineer to design, optimize, and control complex system effectively. So that's why ODE are very important to our future engineering. Okay, so that's all from our group. So thank you.